going to go through each of the parts. If yours doesn't match it exactly, maybe you chose a different variable, that's fine. But if your answers are a little off, we need to double check those. Okay, you should have highlighted, circled, underlined important information. For part A, your equation should look like this, except it would be total equals 0.18 m plus 27.6. If you put the total on this side, that's fine. If you switch those, that's also fine. B is going to look the same, except with the different numbers. C, you needed to calculate the total cost. So you were looking for what it equals by putting 280 into both. Then part D, explain which is the better deal. Glue was cheaper. If you got red was cheaper, double check that for this one. E was similar to C, but now you're changing it to 400 miles. Putting those in and seeing the different costs. This one also asks which one has a lower cost. So for more miles, the red has a lower cost, but for lower amount of miles, the blue one has a cheaper cost. Then F and G ask about miles. So you're given the total cost, so you would put that where your equals is, and then solve. So F would be 242.22, and then G would be 307.14. Do you have questions about any of these? I meant to mention this the other day, maybe I did, I don't remember. When you are dealing with word problems and you get decimals, depending on the type of problem or what you're looking for, some decimals are okay, some are not. Miles can be decimals because you have to count to get to a certain mile. Amounts or costs can be decimals, but only to 2 decimals. If you're looking for amounts of something, like people, decimals are not okay. Or amounts of things that we can't like cut in half or into any part of the decimal. So think about, does this decimal make sense when you get a word problem? Because sometimes it will, sometimes it won't. Okay. You all have a new set of notes. Well, it's like a continuation of the other set of notes. We're still solving, but now we're solving with more steps. Because before we were just solving multi-set equations, now we're solving with variables on both sides. So this would be the new set of notes I put on your desk. So one way to kind of help you remember your steps is this mnemonic, don't call me after midnight. This stands for distribute, combine like terms, move the variable or constant, by adding or subtracting. You may have to do this twice, so move the variable and then move the constant. I'll show you later how to do this simultaneously. And then multiply or divide to get the variable by itself. So kind of the same steps as the last set of equations we were doing, but a little bit more because of that move the variable or constant. We kind of have to do both. In this case, we're going to show both steps, but later we'll be doing them both at the same time. So then step 1, distribute. We can do this on both sides. at the same time. Distribute, so we have 8x plus 4. Bring everything else down. Minus 2x equals 8 plus 4x plus 4. Combine like terms on the same side only. So do we have like terms on this side?
Yes.
Yes. What are those?
X and 2x.
Combine those to get your 6x. Bring down everything else. Do we have like terms on this side?
Yes.
Yes. What are those?
1.
We got 28 plus 4x. So when you're combining your like terms, it's just on the same side. You're doing whatever it says. Then, when you get to this step, you have choices. You have 4 different choices. 6x, 4, 28, and 4x. You can choose what you want to move first. So of those 4 terms, what do we want to move first? 4. If you didn't want to move the 6x and you want to move something else, go for it. You will get the same answer as long as our math is correct. So to move 6x to the other side, we would be doing we would add or subtract. Positive. When we have variables on the same side, our goal is to get all the variables on one side and the constants on the other. So we move the variables to the right. Now we have to move the constants back to the left. So we have to get rid of 28. So after you combine your like terms, you move one thing by adding or subtracting, and then move the other by adding or subtracting. So we kind of did this twice. And then we could divide. This is like the basics of every multi-step equation with variables on both sides. There's like some minor things that we're going to add in, but it's basically if you can solve this, you can do the majority of all of them. Do we have any questions on that process so far? I showed you how to check yourself in Desmos. Yes, no. Some of you are saying yes, some of you are confused. So really quickly, I'm just going to put this in to Desmos so you can see what happens. Someone read that entire thing off to me. Just whatever the equation was.
4 parentheses 2x plus 1 parentheses minus 2x equals 8 plus 4 parentheses x plus 1.
So if you put in an equation into Desmos, it will show you a line wherever that line is. The x value of that point would be your answer. So you would write x equals 12. You would need to still show your work, but this is a good way to double check it, just so that we're on the same page. Okay, go on to the next page. So this is similar to what we did the other day, where we were putting in the different steps, properties of equality for different things. Now these have equations that have variables on both sides. So we'll do a couple and then go do a couple. So just like before, the first one is given. we're looking at what did they do from step 1 to step 2? Go ahead, Kylie.
minus 2x.
Okay. So they got rid of this k by subtracting it to the other side, so your subtraction property of equality. And then from step 2 to step 3, so they subtracted to get negative 16. So they got it. They got it. So addition property of equality. And then step 3 to step 4. Both sides by 8. Division property of equality. Question on example 4 before we move on. So we're going to skip 5 and then do either 6 or 7. I'll let you guys choose. 6 or 7. 7. Okay. So the original is given. What did we do from step 1 to step 2? Distribute. Negative 2 to everything, and then negative 1 to everything. Step 2 to step 3. Combine terms. Because we had 3 terms, now we have 2, so they combine the 14 minus 16 and the 5x minus 3x. Step 3 to step 4. So this one they added, or this one they added? They added the negative to the positive, but then wouldn't that be over here? So then opposite. And then step 4 to step 5. We added what?
2.
And last step 5 to 6. Do we have any questions on example 7 before we continue? So I'm going to have you guys do 5 and 6, but I'm going to give you one of the lines in 5. Step 4 is your symmetric property, which is not given. But that symmetric property just means the order changes. Negative 6 equals n, and n equals negative 6. They just change the order of it. Try example 5, try example 6. I'll give you a couple minutes to do that. Compare your answers with the people around you, see if you got the same thing. Talk with them about it if you got something different, and then double check your answers with mine. And you get them all correct. Good, good, good. If you didn't go back and fix them, do we have any questions about any of those? So as I mentioned before, you won't be tested on knowing the properties exactly, but you will be, you'll need to know how to apply them. Go to the next On this page, there are different equations. Look and see any that you wouldn't know how to start, you want to do together, you have questions about, any of those. I will say 4, 6, and 7 are all the same, so we're not going to do 7. Okay. 9. Okay. This is a good list. If we have more, we'll go back and do that here in a second. Okay, so let's start with number 3. Our goal is to get the variables on the same side. How could we do that here?
Go ahead, copy the end and your
Say that one more time, sorry.
subtract this.
What would we get from that? And then divide, and how much you get? You divide it. Okay, so don't let the decimals, fractions confuse you. You're still doing the same process. Okay. Number 4. This will apply for 6 and 7 and any other problems you see like this. Anytime you see a fraction that equals another fraction, you want to know what you have to do to get them out of these fractions. Say that one more time. So if we were in the process of solving, then that would work. But this wouldn't really help with that part because they're still equals. So what that means is not multiplying directly across, but taking whatever's in one numerator and multiplying it diagonally, and then doing the same thing here. So we're going to rewrite it. 9, and then in parentheses, 5x plus 5 equals 3, then in parentheses, 9x minus 3. So every time you see a set of fractions that equal another set of fractions, you're going to set it up like this. It does not matter if you put this part on the right or on the left, you're going to get the same thing as long as you solve and do your math correctly. Okay, so let's distribute. And I'm going to show you how to start doing the moving simultaneously. So what do we want to move first? Sure. So if we're moving 27x, we would have to subtract it to get it to the other side. Because we're moving all the variable terms to the left, we have to move all the constant terms to the right. So we would need to subtract 45. that at the same time. Now, if it still helps you to do it in 2 steps, that's fine, but we don't have to do that. So go ahead and subtract these. Tell me what you get. What would you get? Negative 7.
Negative 3.
As the final answer. Sorry. What's just this part?
18x equals negative.
And when we divide, we would get negative. Do we have any questions on that one before we continue? Anything that didn't make sense? Okay. Number 5 is similar to how we not started this, but the next step. Don't let the 1/3 confuse you. Just like when we were simplifying, you can just distribute. So here, this would just be 30m minus 18. What would this side be? 8m plus 1. And again, you have choices. What do we want to move first? We get rid of 8m, move that to the left, then we have to get rid of 18, move it to the right. Divide, and m is 1. What would be our first step in number 6? Cross multiply. Even if the fraction looks different, I didn't include that. Anytime you have a fraction equals another fraction, you're always going to cross multiply. Whatever the single number is will be what you multiply to the other piece. So 7 times n minus plus 10, sorry, n parentheses, and then 8 times n plus 2. Start to distribute. Like this or this. If you put 8 parentheses n plus 8 on the left, that's fine. What do we want to move first? When I choose things to move, I try and look for the easiest thing, or what would keep things positive. So if I'm moving 7n to the right, I can move 64 to the left. This just becomes n, this just becomes 6. That is our answer, we don't have to do anything else. If we had moved the 8n instead, we'd end up with a negative on both sides, and then we'd have to divide. So it would create an extra step. So look and see what could keep it positive, because that might help. Questions about number 6? And then 9, we're going to distribute twice on the same side. Be careful with your negatives. Double check that you're multiplying 2 negatives so you get a positive. What's our next step? Combine fractions. So 8y minus 2y, 32 plus 2. And you combine like terms, do whatever it says, not the opposite. 6y plus 34. Then we have choices. What do we want to move first? 34, okay. Subtract 34 on both sides. Add 3y on both sides. So we have 9y equals 36. Double check that math one. And then divide so that y equals 4. How do we feel about solving equations with variables on both sides as of right now? Good. Okay, just need more practice. Not good, I don't get what we're doing. Alright, I'm going to have you guys do a couple and then we'll move on to the next thing. We did a lot. So, 7 and 8. Try those two. No one's confident in their answers? We agree or disagree with a equals negative 5. For number 8. Agree. See some agrees. Negative 5 was the correct answer for negative 8. Sorry, I cannot speak today. So good job on that. Anyone want to try number 7? No one can come there with that one. Okay. First step, cross multiply. The fraction that equals another fraction. So if that's not what you did, go back and restart that process. So 8 times b minus 4 equals 3 times b minus 3. Distribute. And then pick what you want to move. So let's say I got rid of 3b and added 32. That's fine. Because everyone thinks the answer is wrong, but it's right. Yes. If it's a nice enough decimal, you can. You can also just leave it as a fraction. So if it's something over 9, over 7, over 3, over 6, leave it as a fraction. Because leave over 6 and it's not simplified. Anything else you could probably put as a decimal. Right? Questions on that? We've been sitting for a while, so let's stand, stretch our limbs, get some blood flow back into everywhere. So everyone take a second, stand. Take a second and stand. Stretch, move side to side, wiggle your fingers, toes, arms, legs, all of your legs. Stretching.
So does it stretch? Sorry.
I keep trying to stretch. I still have my neck on, so like my neck hurts. But it's only something so much. Anyway, next page. So all the problems we just did have one solution. These are going to be special cases, which you can see the different names, but we're going to talk about them. You won't know it's a special case until you start to solve it. So it'll look just like a regular problem. So how do we start this one? And then combine terms. Okay. Before we continue, I want you to look at this equation. Tell me what you notice. Okay, so solving wise, you'll end up with 0. That's important. But what about this right here? What do you notice? Anything stand out? Okay. These are the same. Anything else? These numbers are different. Those are going to be a signifier that this is going to be a special case. We'll talk about which one and how you tell that here in a moment. So let's keep solving this. We choose something so that we can move it. Okay, so 5 and 5x. Okay, so if we're subtracting 5x to both sides, and then let's say I move this to the right, even though it could be looked at either way, and I'm moving 12 to the left, what happens with my x's?
0.
It's 0. This is going to tell you have a special case. Your variables cancel, and you have two numbers that don't equal each other. This is no solution. So you can find no solution a couple different ways. You solve it all the way through, you get two different numbers. You see and that your variables canceled. Also here, if you see that you have the same coefficient but two different constants, at that point you could stop and say this is no solution. Right? When this is the block off part, so if you want to write that, you can. If we were checking something that actually had a solution, we would take the number, we would put it back in, it would work. For no solution, there aren't any numbers you could put in that would ever work. So I could put 1, 10, 50, 100, a million, -10, -50, -1 million, all the decimals, all the fractions, none of them would work. Right, so that's one of your special cases, no solution. You can see the name and what this is going to be, but we'll still work this one out. Right, so same as before, distribute. Combine your like terms. What do you notice about this one? They're the same on both sides. The coefficients and the constants. That's going to tell you about this special case. But let's keep solving. What do we want to move first? What do we want to If we're subtracting 16, you have to add 10. What happens?
0 on both sides.
0 on both sides. Everything cancels. But this is a true statement. So this would be your infinitely many solutions. Write that in if you don't already see it. Or IMS. And that means every number possible could work. So all the numbers I just listed, you could put any of those in and they will always work. Now, sometimes you could get a special case by accident. You could cancel your variables by accident, so be careful. Double check your work. Right. In a moment, I'm going to have you try a couple, but before that, I need everyone to have this. There are boxes. I'm going to have you fill out those boxes really quickly. Under one solution, the variable terms are different. So that's the word that goes in that box, different. Infinitely many solutions, the variable terms are the same. Both sides are equal. In the no solution box, variable terms are the same. Both sides are not equal. So you're welcome to try these examples, not at this moment, but when you feel like it. There are different examples, wording about what you'll see when you solve those. On the back, I'm going to show you what this looks like in Desmos. Okay, so I'm going to use the examples from those boxes to show you what these look like. So if we have one solution, so I typed in this, it will look like a line. Whatever that line is, look at the x value. The answer to that equation would be x equals -2. That would be most of your equations. Now some of your equations, so like for infinitely many, if I put this in, you won't see anything. And it's not an error with Desmos, it's just you don't see anything. So what you have to do instead is put in each side separately. And I don't know if you saw what just happened, but the two lines overlapped. they graph on top of each other. So that's what this second one is showing, that they're overlapping, graphing on top of each other. And then for no solution, again, it will not graph anything, so you have to graph them separately. And they will show you two lines. So this is what you're missing, so you can draw this in. There'll be two parallel lines. We'll talk more about parallel lines later. But they'll be in the same direction. They won't ever intersect. When we talk about slope, that will apply. Right? That way you know what they look like when you go to check your answers in Desmos when you're at home practicing Delta Math. You can use Desmos to check your answers, and if they look like any of those, be on the lookout for that. Right. Questions on the different types of solutions? I want you to practice numbers 3 and 4. Talk to each other, check your answers with each other. If you have questions or you might help, let me know. We're on board. Do we agree or disagree? Agree. We should have gotten 0 equals 0, infinitely many solutions. Anyone want to come to 4? We all avoid the ones with the fractions. Okay, so there were different ways you could have done number 4. One, you could have started with combining like terms and then moving. You could have also moved things before combining like terms. As long as you do them eventually, it doesn't matter. So if we combine our like terms, we had 2/5 h minus 7 equal 2/5 h plus 3. This should tell you that we have different coefficients, so it's going to be no solution. So you could stop there if you recognize that, or keep going. NS or no solution, you could write it out. If you added 7 instead of subtracting 3, you would end up with 10 equals 0. It's still no solution either way. Do you have any questions about that? Okay. We've been doing a lot today. I'm tired. You're tired. We're going to stop today. But next class, we're going to finish these notes and you're going to have time to practice. Before you put your calculators up, listen. You have 2 Delta Math due tomorrow. If you have not done them, now would be the ideal time to do them so you don't have to worry about them tomorrow or the weekend, things like that. You have time to get them done and ask questions, so I would use this time to do that.